All right, welcome back to the deep dive. Today we'll be digging into something that's pretty fundamental when it comes to programming. We're talking about procedures, these prepackaged sets of instructions.
Yeah, procedures, think of them as like power tools.
Hmm.
You don't want to build a house with just a hammer, right? You need a whole set of specialized tools. Procedures are kind of like that. They let you group instructions together and give them a name so you can use them over and over again without having to rewrite the same code a zillion times.
Exactly. And I know our listeners are all about efficiency. So procedures are a key part of writing clean, reusable code. And as always, we're going to make sure this deep dive is approachable and fun, even if you're not a coding whiz.
Yeah.
Just a quick heads up, we'll be drawing on some concepts and examples from AP Computer Science Principles. So if you've ever taken that course, some of this might sound familiar. But even if you haven't, don't worry, we'll break it all down.
Yeah, for sure. We're going to start by focusing on two main types of procedures. Those that simply perform a set of actions, and those that actually calculate or evaluate something and then give you back a result, a specific value that you can use somewhere else in your program.
Okay, let's kick things off with the action-oriented procedures. Could you give us an example to kind of illustrate what that means in a real-world coding scenario?
Sure. Imagine you're programming a robot to navigate a maze or a grid. Let's say this robot frequently encounters a specific obstacle that requires a particular sequence of moves to get around it. Instead of writing out that entire sequence every time the robot hits this obstacle, you can create a procedure for it.
Okay, so we could call this procedure detour right. And inside this procedure, we'd put all the specific instructions, maybe turning right, moving forward a few steps, then turning left to get back on track.
Exactly. So when you call detour right in your main program, the robot will execute those actions in that exact order. But it's not going to send back a message saying like detour complete or anything like that. It just does the actions and moves on.
Right. So it's kind of like a mini program embedded within the main program. If our robot's instructions are move forward, and then detour right, what happens step by step?
Okay, so the robot moves forward again, and then it hits that call to detour right. At that point, the program temporarily jumps out of the main sequence of instructions and dives into that detour right procedure. Inside that procedure, you might have instructions like rotate right, then move forward, then rotate left, move forward again, maybe twice this time, then another rotate left, one more move forward, and finally a rotate right to get it facing in the original direction.
So it goes through that whole detour routine.
Yep, and once all the instructions within detour right are complete, the program seamlessly jumps back to the main program right where it left off.
Got it. So the next instruction after detour right might be something like move forward again, and then maybe rotate right. The key takeaway here is that these action-oriented procedures, you just use their name to trigger that set of actions, and then the program picks up where it left off in the main flow. Now let's delve into the procedures that do give us back a value, a result we can work with.
Right. These procedures are like little calculation machines. You feed them some input, they crunch the numbers, or perform some kind of evaluation based on logic, and then they hand you back a result that you can use.
Okay, so it's not just about performing actions. It's about getting a specific outcome that we can then plug in somewhere else in our code. I remember learning about this in AP CSP, something about parameters and arguments. Can you refresh our memory on that?
Absolutely. Parameters are like the input slots for a procedure. When you define a procedure, you specify the parameters it needs to work with. Arguments, on the other hand, are the actual values you provide when you call the procedure. Let's imagine a procedure to find the smaller of two numbers. We might define it with parameters, maybe calling them number 1 and number 2, and when we actually use the procedure, we'd provide the specific numbers we want to compare as the arguments.
So if we want to find the minimum between, say, -8 and -12, those would be our arguments.
Exactly. Now, let's look at a slightly more complex example. Say we have a procedure called summarize that takes two numbers as parameters. Let's call them number A and number B. If we call summarize nagget8, nagget12, then nagget8 would be the value assigned to the parameter number A, and nagget12 would be assigned to number B. But here's where it gets interesting. Summarize itself might not directly return a final value. Instead, it could call another procedure internally to handle part of its task.
Interesting. So it's like a delegation process.
Exactly, like a project manager breaking down a big project into smaller, more manageable tasks. So summarize might be responsible for the overall summary, but it could call a separate procedure called minimum to figure out which of those two numbers, number A and number B, is smaller.
Okay, so inside summarize, we might have a line of code that's calling minimum and passing along those same values, megas 8, negas to 12.
Yep, exactly. So within the minimum procedure, these values would be assigned to its own parameters, maybe named number 1 and number 2. So number 1 would be negative 8 and number 2 would be negative 12. And the minimum procedure's only job is to compare these two and figure out which one is smaller. If number 1 is less than number 2, it returns number 1. Otherwise, it returns number 2. In our example, negative 8 is not less than negative 12, so minimum would return negative 12.
Okay, so this is where that distinction between the types of procedures comes in. Because minimum returns a value, we need a way to grab that returned value, that negative 12, and actually use it within summarize. And that's where assignment statements come in, right? It's like catching a ball, someone throws to you, you got to put your hands out to receive it.
Exactly. So we need to use minimum in a way that captures the value it returns. We could have a line like minimum value, that's our variable name gets. That's the assignment symbol, minimum number A, number B. So basically we're calling minimum with minimum 8 and negative 12, and then whatever value it returns, in this case negative 12, gets stored in that variable minimum value.
Okay, that makes sense. And then back in our summarize procedure, we can use that stored minimum value however we need to. Maybe we display it to the user or use it in some other calculation.
Precisely. We could have something like display the minimum number is minimum value, and that would show up as the minimum number is minus 12. The key point here is if minimum didn't return a value, or if we didn't assign that returned value to a variable, that net equal 12 would essentially disappear into the void. We wouldn't be able to use it.
Got it. Now, I want to zoom in on the return statement. That's what actually allows a procedure to send back a value, right?
Yeah, the return statement is like the messenger pigeon. It carries the result back to the main program or wherever the procedure was called from. And the cool thing is, as soon as a return statement is encountered, the procedure stops right there. Anything that comes after the return is ignored. It's like, mission accomplished, I'm out of here.
That sounds super useful for controlling the flow of the program. Can you walk us through an example to show how that works in practice?
Okay, let's say we have a procedure called round value that rounds a number to the nearest whole number. And let's call it with the argument 4.7. Now, inside round value, there's some math happening. First, let's say it creates a temporary variable, we can call it temp, and sets it to the argument multiplied by 10. So in this case, temp would be 4.7 times 10, which is 47. Then it creates another variable, maybe called last digit, and sets it to the remainder when temp is divided by 10. So last digit would be 7 in this case.
Right, so essentially grabbing that decimal part and isolating it.
Exactly. Then it updates temp by subtracting last digit. So temp becomes 47 minus 7, which is 40. And finally, it divides temp by 10, so temp is now 4.
Okay, so we've got that whole number part isolated now. What happens next?
This is where the magic of the return statement comes in. There's usually a condition that determines what value gets returned. So in a round value procedure, there might be a line like, if last digit is greater than 5, then return temp plus 1. In our case, last digit is 7, which is greater than 5. So the procedure would execute that return temp plus 1, meaning it would return 4 plus 1, which is 5. And because it hit that return statement, everything else that might be in the round value procedure after that is just completely ignored. It's done.
So it's like a shortcut exit.
Exactly. Now, what if we call round value with 3.2?
Yeah, good question. What happens when the condition isn't met?
Well, let's walk through it. Temp is going to be 3.2 times 10, which is 32. Last digit is going to be the remainder of 32 divided by 10, so 2. Temp gets updated to 32 minus 2, which is 30. And then temp becomes 30 divided by 10, which is 3. Now, it hits that conditional statement if last digit, which is now 2, is greater than 5. But this time, the condition is false. So the code inside that F block, the return temp plus 1, that doesn't get executed at all.
Right, it skips over that.
Exactly. Now, depending on how the round value procedure is written, there might be an ELSE block with a different return statement, or there might just be a final return statement at the very end. If there's no specific instruction for when the condition is false, the procedure might just return the current value of temp, which in this case is 3. The point is, a procedure can have multiple return statements, but only one of them is going to be executed for any given call to the procedure.
Okay, that makes sense. Now, we've covered a lot of ground here. We've talked about how procedures help us organize our code. We've seen how procedures can be used to perform actions or to calculate and return values. And we've looked at the roles of parameters, arguments, and the return statement. But now let's talk about how we actually write the code to call these procedures and make them do their thing.
Absolutely. As we discussed before, the way you call a procedure depends on whether it's designed to return a value or not. For procedures that don't return a value, like our detour rate example, You simply use the name of the procedure followed by any arguments it needs in parentheses. But if a procedure does return a value, you typically want to use that value somehow, so you'll usually include the call to the procedure as part of a larger instruction, like an assignment statement, where you store the return value in a variable for later use.
Okay, so let's say we have a procedure called apply discount that takes two inputs, the original cost of an item and the percentage discount. And let's assume this procedure calculates and returns the final discounted price. How would we write the code to use this?
Okay, so since apply discount returns a value, we would need to assign that return value to a variable. So a typical line of code might look something like this. Price, that's our variable name, gets, that's the assignment symbol, apply discount 60, 20. So in this case, 60 is the argument being passed to the cost parameter, and 20 is the argument being passed to the percent discounted parameter.
Okay, so those numbers represent the actual values we want to use for the calculation.
Exactly. The apply discount procedure would then go and do its calculations using those values, and in this case, the result would be 48, which is then stored in the price variable.
And it's important to keep track of what each procedure expects as input and what kind of output it produces. Like if we had another procedure called apply tax that also takes a price as input, we would need to make sure we're passing it the discounted price, not the original price.
Absolutely, that's crucial. You got to pay attention to the context and make sure the arguments you're providing make sense for what you're trying to accomplish in your program. For instance, let's say we have a procedure called convert Fahrenheit that takes one parameter, the temperature in Fahrenheit, and returns the equivalent temperature in Celsius. When you call this procedure, you got to make sure the argument you provide is indeed a Fahrenheit temperature.
So it could be a specific number you've typed in, or it could be a value that's stored in a variable.
Exactly. Like if you have a variable called outside temperature in Fahrenheit, you could call convert Fahrenheit using that variable as the argument. So the line of code would look like Celsius temp, that's our new variable, gets the assignment symbol, convert Fahrenheit, outside temperature in Fahrenheit.
Perfect. So for procedures that return a value, the call is usually part of an assignment statement. But what about those procedures that just do something, like draw a shape on the screen without returning any value?
For those types of procedures, you simply call them by their name, followed by any arguments they need, enclosed in parentheses. Let's say we have a procedure called draw square that takes three parameters: the x-coordinate and the coordinate of the bottom left corner of the square and the side length of the square. To draw a square starting at the coordinates 2, 3 with a side length of 4, we would just write draw square 2, 3, 4.
So when the program encounters that line, it jumps over to the draw square procedure, executes those instructions using those specific values, and then returns to the main program.
Exactly. And the beauty of it is you can call that same draw square procedure multiple times with different arguments to draw multiple squares at different locations or with different sizes.
That's where the reusability shines through.
Yep. Let's say we want to draw two squares. The first one starts at 2, 3 with a side length of 4, and the second one starts at 4, 2, and also has a side length of 4. We could do that with just 2 lines of code. Draw square 2, 3, 4, and then draw square 4, 2, 4.
Now, what if we flip those 2 lines around? Would it make a difference?
It might not. It depends on how the drawing system is set up. Visually, you might end up with the same 2 squares in the same places, but the order they were drawn might be different. It highlights the fact that the order you call procedures in your program can matter.
Got it. So looking back, we've really unpacked a lot about procedures, what they are, how they work, the different types, and how they're essential for writing clean, reusable code. We've talked about parameters, arguments, and the return statement, and we've seen how they all fit together.
Exactly. Mastering these core concepts is a huge step towards becoming a more skilled programmer. It allows you to write code that's not only more efficient, but also more organized and easier to understand, both for yourself and for anyone else who might be reading your code.
So for our listeners out there, I want to leave you with a thought. We've seen how breaking down complex tasks into smaller, named units, like procedures, leads to more organized and reusable code. But how does this concept apply to other areas of life, beyond programming? How can you break down your own goals or projects into smaller, well-defined steps that you can maybe even reuse in different situations?
That's a great question to reflect on. And while you're thinking about that, consider the software and apps you use every day. Can you spot any features or functionalities that you think might be implemented using procedures behind the scenes? Recognizing these concepts and the technology you interact with can really deepen your understanding of how these programming principles are used in the real world.
All right, folks, that's a wrap for this deep dive into procedures. Thanks for joining us, and we'll catch you next time on The Deep Dive.
See you then.